Good. So our recording has started. I just want to thank everybody again here for joining us for another one of the Siemens webinars or seminars. Today we're going to be exploring the world of G-code programming specific to ID part programming for a turning center. To introduce myself, for those of you that may not know me, my name is Chris Pollock. I'm the Virtual Technical Application Center Manager. So basically what that means is I develop a lot of this online content for Siemens, or work certainly with a lot of close colleagues in developing material for you guys. So it's kind of all things online. Yes, otherwise known as MrCNC. That is correct. That was one of our attendees just threw that into the Q&A window. I do want to make sure those of you that are new to the platform or the sessions are familiar with some of the key websites for looking for additional material. You know, our kind of our kind of function here is certainly all things operation and programming based, and certainly the websites I'm showing here are centric to that. So our main website or landing site is the CNC for You website. You can see the URL in the upper left hand corner of my screen there. I would say, you know, anything operation program, it's a great place to start. You can see links to the webinars. Certainly we have a full list of past webinars can be found there, as well as a lot of training material. So we do also offer class and classroom environment type sessions. If you go to the training area, we've been doing a lot with the online training classes, and we just scheduled our next series of classes. So I think we're scheduled right out through April now. All of our training classes are 100% complimentary. So by all means, if you guys want to kind of expand your knowledge of the SINUMERIK product, I would suggest checking them out. The online classes are multi-day classes. The way we kind of set it up is you come in the morning, there's a live instructor. So you're going to be working directly with a live instructor, as well as a classroom of other, you know, colleagues and people in the industry. Usually we lecture for about 3 hours, do some class examples, whatnot, and then you guys get a chance to do some homework, and then you come back the next day. Depending on the course, they range from anywhere from 3 to up to 5 days. So certainly a great way to kind of expand your knowledge of SINUMERIK. Additionally, we have just brought back our in-person training. We're all super happy about that. It took some time to get to the point with everything going on that we feel that we can safely bring our classes back. So I am hosting my first 5-axis class this December out of our Elk Grove Village, Illinois Training Center. That's where we hold our in-person instructor-led classes. But if you go to the CNC training on CNC for You, you can see those classes are listed there. So we haven't put out the full list of classes for next year. We're still working on that format, but I would say keep checking back on that site if you're interested in coming out and working with us in person. So again, there'll be a list under the in-person training tab. Those would be for all of our brick and mortar classes in Illinois. So it's right outside of the Elk Grove Village, or the O'Hare Airport in Elk Grove Village. And if you happen to have not seen it before, we have our MrCNC YouTube channel. So there we do put up all the webinars, but we also create a lot of other little mini videos, promotion content, how-to segments. So if you haven't been on it, I would strongly suggest making your way over to YouTube. Just do a quick search for MrCNC and have at it, check it out. And if you guys have any, you know, ideas as far as new content, by all means, send it out. I'm actually doing this webinar today because of a request of one of the people that were watching the shop turn version of this webinar I had done quite some time ago, and was asking if we would do a G-code one. So we certainly take the responses coming in and like to kind of work them into our normal curriculum or format as we move forward. And let us not lose sight of an interesting program we've created. It kind of came out of these times of a lot of working from home. We built what we call our VPE program, our Virtual Product Expert program. And what this is this is basically the ability for you to be able to book time with a product specialist of the SINUMERIK product and actually have a one-on-one discussion. So it would be a online based discussion. We would share our screen, bring up a simulator so we can kind of go through things, all things SINUMERIK. So whether you want a demo on the product or you're interested in learning a little bit about a specific feature or function, the typical events usually last about an hour or so. Daniel Vitullo, my colleague, who is actually, I think, on the line here with us as well. He manages the program. So just reach out to Dan. Simplest thing would be go right to the SINUMERIK website. Under the SINUMERIK training, you will see a link for the virtual product expert. Click on that link. You fill out a quick little questionnaire page, giving us an idea of what you're interested in. Dan will get back to you and schedule up, and Dan will either host it or one of the other guys in the team will, myself included. Okay, so today the material we're going to talk about is going to be specific to the 828 and the 840 controls. Now, I still have the 808 up here because certainly from some of the G-code perspective, there will be commonality. But when you get into the cycles, you will see a difference. So I would say really the core material we're talking about today is really more specific to the 828 and 840. However, it is also pertinent to our latest and greatest control, the SINUMERIK 1. So you guys may or may not be familiar with the SINUMERIK 1. So the SINUMERIK 1 has been recently introduced to the market space, been in the market for about a year now from when we first introduced it. EMO, I think it was last EMO or somewhere thereabouts. Well, EMO was just this year, so it was an event about a year earlier we introduced it. But this control will be long-term replacing our 840D control as our premier product, and it is a very interesting control because it is the first truly natively developed digital twin control. So you actually build up your physical machine tool, and at the same time you have a digital variant from an engineering or commissioning standpoint. You'll get a chance to see here today, this is kind of a little teaser, a piece of software that's using to support the SINUMERIK 1, which is what is going to be replacing our SINUTrain software. So you're going to get to see what this whole digital twin concept looks like when we get into the practical examples. But the main content here, as I mentioned earlier, is to talk about really how do I work with ID type of applications, drilling, boring, grooving, threading, all of those types of tool paths I would do on the inside of a part specific to G-code. So we're going to kind of break that down. We are going to look at two different part examples. So the first part here, we're going to use some of our standard CAN cycles. We're also going to treat this as a part that maybe already has a hole in it, right? So we're just going to work from a part that was pre-blanked, maybe pre-drilled or drilled with a tailstock. And then once we get through this part, we are also going to get into something a little more elaborate where we'll use our actual contour editor. So in this case, we'll draw in a regular shape. This is the point where we're going to introduce you to the drilling cycles. Drilling cycles do look a little different than they look over in shop turn. Shop turn, we're used to seeing what we call centric drilling cycles. You don't see that over in the G-code side. So I'm going to explain all that as we get to it. But here we're going to implement some drilling, come through and do some ID turning as well, a little more complex shapes. But before we get into the actual part programming examples, I do want to spend a little time talking about tool setup, specific to defining these tools that we're going to be using for internal operations. So how do I set up a drill? What are some different ways to treat like an insertable drill? You can start to use multiple cutting edges, can be pretty handy in some of these applications. So let's take a few minutes and explore the setup side of the control. And then once we've done that, we'll switch over and get into some G-code programming. So when we start talking about internal jobs, we are specifically talking about those four tool orientations that we find in the center of our screen there. So if we look, there's a P1, P2, P3, and P4. So this would be for standard ID turning. Now the upper two, the P3 and P4 up are two icons. That would be really representing a machine that has a rear turret. If I have a machine with a front turret, then my tool orientations would be in the lower two locations. And for some reason, if I happen to have a machine that had an upper and a lower turret, then obviously I could flip between the two. Now, generally in our system, the way it would work is the icon you're looking at. So if I look to the lower section of my screen there, I have a roughing tool, right? And then I have the roughing and the finishing. And here we see there's an insert position, and the first one on the left should really always represent a standard OD tool. So if I'm choosing this first position, whether it be roughing or finishing, should represent the way the tool is physically mounted in the machine, assuming the OEM commissioned your machine properly. So with that being said, the third insert right over here, right in this tool position, the third insert is going to signify an ID tool. So if I happen to have the pictures you're seeing there would be on a rear turret style machine. If I happen to have a front turret, those two icons would actually switch, but it would match the way it sits in the machine. So that third position from the left is always going to represent an ID tool. So when you're building a turning tool, just keep that in mind. Now, certainly, if I'm not using a handed tool, you can then expand further and get to your neutral orientations. We see that on the far right side of the screen. So there's a lot of different configurations. If I'm back turning, then I might use that fourth icon over. That would define a back turning style tool, or maybe I have a main spindle and a counter spindle. I mean, that's where you get into all these different orientation positions. But just knowing that little trick that, hey, that third position from the left, that always signifies an ID tool. It's typically what you're going to use when you start to build up these tools. Now, when it comes to actually figuring out what I need to kind of tell the system, it is pretty handy to have a good grasp on, your standard ISO definition of a boring bar. And that's what we're really showing here. So when I'm going to kind of start defining a tool, if I start to look at my part description here, the ISO description, I can get a good understanding of what this tool looks like, and then start to apply the information over to the definition of the tool as I create it or build it. So this first position, the letter A, which is the first spot, that's going to tell me what the bar type is, right? So is it a steel shank boring bar with coolant through it? Is it a heavy metal bar, anti-vibe? That's going to signify in this first position. So normally that's not something that we need to know as far as the setup of the machine. We do also have the next position, which would stipulate the bar diameter. Now in this case, I don't need to tell the control that, but I'm going to need to know that when I'm going to actually set up the bar. Maybe I need to know what kind of OD holder I'm going to mount it in, or do I need a reducing sleeve to hold it? One of the big things that you don't normally get from this ISO description is the minimum bore diameter of the bar. Now that is a piece of information when you deal with ID tools that's very important. And that's really telling you what the smallest hole that I would have in a part needs to be for me to fit this bar into. So if I have a boring bar, maybe it's got a 5/8 shank. Well, that doesn't mean that the minimum bore is 5/8. It's probably something larger than that, because the cutting edge is always offset from that. So maybe the minimum bore is 3/4 inch diameter. Well, if I got a 3/4 inch minimum boring bar and I try to put it in a 5/8 hole, I'm going to catch the back side of that boring bar with the back side of the hole. So that's where the minimum bore size comes into play. So that's a piece of information you're certainly going to want to need to know. However, you don't have to put it in our description at this point. You are going to want to get into telling the system what type of insert geometry it is. So that comes in play when you get to position number 5, right? You see the A, B, C, or D, and it'll tell you if it's an 80 degree or 55. Well, that's going to relate down in our description here to the 80. That's going to tell me the shape of the tool. When I go into the next page, I get into my relief angle. That's the 6th place over. So we have the L, FS. So this is going to tell me what the orientation of the tool is. And that would be this number right here to the left of my 80. And that's telling me where the insert orientation is. What's unique about the SINUMERIK control, and not a lot of controls have this capability, we not only know where the front edge of the insert is, but we know where the back edge of the insert is. Most lathes only know where the front edge of the insert is. And if I send the tool somewhere where I'm going into like a pocket, maybe an hourglass profile, and potentially the back side of that tool can catch the part, well, at that point, typical controls would not know that, and you could basically gouge or overcut your part. In the SINUMERIK control, by knowing that orientation angle and then the insert angle, I know the back side of the tool, so it keeps us from overcutting. So it's what we have insert checking and gouge detection built into the control, but it's critical that I know this orientation angle. The other piece of the puzzle comes into the tool nose radius. I guess it's not shown in this screen, would be a piece, I think it's actually 10 if memory serves me, that'll show you the nose radius of the insert. But that's another piece of the puzzle. I have to tell it for the radius. My length offsets, that's really going to be a nature of how the boring bar is physically mounted in the machine. So by knowing this little bit of information, I can start to set up these tools, build up these ID turning tools specific for boring bars. Now, what about when I get to a drill, right? So a drill, generally we're going to want to work off the center of the tool. So normally I would come in and I would define some kind of offset at the center of the tool. However, depending on the drill type, insert drills have a tendency to actually make really good boring bars because there's a lot of mass to them. They're very stout and they're quite stable. So this is a good example of using what we refer to as multiple cutting edges. So in our system, you can create up to 9 offsets for any given tool. And those 9 offsets would then allow me to establish 2 separate offsets, one at the center of my insert drill and one at the leading edge of one of my inserts. Now I do have to make sure when I mount the tool that insert is flat, right? I don't want to rotate the drill up. Then obviously my cutting edge wouldn't be parallel with the x-axis, but as long as I physically time it properly in my turret or in my tool post, I can then start to use this, like this example, and actually set up 2 different cutting edges. So let's kind of take a look at how that would work in a practical example. So in the system, and we are now going to switch over to this new piece of software that we call Run My Virtual Machine. Now, what's cool with Run My Virtual Machine, let's bring up the manual keyboard. What's cool with Run My Virtual Machine is it's going to look like SINUTrain. So basically everything you guys are used to doing and using inside of SINUTrain exists over here. But what I also have is an actual digital twin of the machine. So as I move the machine around, we'll crank up my speeds, I can see the true motion of the machine is going to occur. What really becomes handy with this type of technology is I can mimic the entire setup process that I would normally do in a real world scenario, and I can do it virtually here. So if I want to see if I have nesting issues, that can always be an interesting challenge when I start to place these boring bars in this turret. Well, are they going to hit my chuck? How far out do I have to stick my part out? Do I need to have different jaws? Right? Those are all the things I generally don't know when I am doing programming upstairs. I get down the floor and now I have to kind of find all those things out. It's going to slow me down. It's going to keep my machine from running. So we can reproduce a lot of these scenarios. And in my case, I want to kind of talk about the setup a little bit. So we're talking about an insert drill specifically. So I have created an insert drill, and we'll show you here, and I just created it with our basic solid drill scenario. So let's introduce you to the insert drill. Here we spin it around, right? So this is a basic representation of the insert drill. So when I first needed to set this drill up, I probably would have brought it down, maybe indicated the holder, or I could have bumped up to the side of the part, and I can use my measure tool to allow me to set up my physical location, right? My tool offset. So in this case, we're showing you how to touch off to the side of the part. In a couple other slides, I'll show you how to indicate, and we'll talk about that. But when I want to actually set up a secondary offset, what I needed to do in my offset table is I have my drill already created. So what I did was I created a second cutting edge. Now you don't see the button pop up now because this is the loaded tool. But if I grab any different tool, you see where I get this little cutting edge button. So once I say, yes, I want another cutting edge, see how it created a new line here? And I can keep doing this up to 9 times. So for every new cutting edge, I can now define completely new offsets. I can actually change the configuration of the tool. So what I do in that scenario with the drill, and I'm just going to delete these cutting edges because we don't need those two. What I do in the scenario of the drill is I make my first one, I call it a drill. In this case, I called mine a solid drill. You could just call it a standard drill if you wanted to. I would just have to have negated the tip angle, right? Because the insert drill is usually flat. And then on the second one, I define this as an ID turning tool. So remember I was saying I use the third position over here. So that would be the location that I would want to choose to define an ID turning tool. So now I can actually drill a hole, come in, take a light cut, measure the ID of that hole, set the tool as if I was setting a standard OD tool, right? So I would be here and measure tool under X, but instead of it being a drill, once I load the offset for my cutting edge number 2, so all it's doing is changing the D number. Now the system's going to think that this is an ID tool. So if I go to measure, not that, measure tool, and I'm an X, now I would come in, touch a known bore, probably measure it, right? So I'd like to take a little cut because it'd be a little more accurate than just when I first drilled that hole. Mic it up, plug in the diameter that I've cut to. So an example of using this would kind of look like this. Here I created a nice little simple example here where I came in, I faced off the part real quickly, and then I'm going to go and drill a hole. So I'm going to use my solid drill with D1. This is just my little drilling cycle. We'll go into all that a little bit later. And then you notice right here, I switch over to D2. And now I can treat this as an ID turning operation. So for the actual cutting of it, if I was to simulate the part, it's going to look like I switched tools. But when we run it, you're going to see that I'm actually maintaining the same tool the whole time, right? So here, maybe we'll go to a side view and go half cut. Here you see I got some internal on the part. Maybe we'll re-simulate it real fast for you guys. There's our little job. Now, what I want you to watch is what this is going to look like when we really run the job. All right, so we're in auto. I'll bring up our simultaneous record so we can get a little bit of an idea of what's happening here. All right. So first I come down, face off my part. Now we're going to spin the turret around, drill our hole, and now watch the simulation showed a turning tool, but I'm actually maintaining the physical drill the whole time. And then I switched to an ID grooving tool and did a couple other operations. So that's really how I can start to use these different cutting edges. Other ways to use cutting edges is maybe I had a little gang tool set up. So I have one bank that can do turning and maybe threading and grooving, or that's pretty common. When you get to these turrets, you don't have a lot of turret locations, right? That's usually pretty limited. So you get somewhat creative as far as how you will set up these machines for sure. Now, when it comes to setting the drill, there's certainly an aspect of it I wanted to talk about here. And what that really is you got to kind of watch out how you go in and set the drill. Now, the internal tools, the turning tools, we talked about that. It's really a lot like setting up an OD tool. So any of you guys that have already set up an OD tool on our machine, they're just doing it in reverse. Inverse. The only difference here is I do need to have a part with a hole in it. right? So we do have to have a part that physically is predefined with a hole. But when I get to setting up my drills, if I'm not going to touch off the side of the part, I do have to be careful with what offsets I have established in the drill. See, normally what I like to do is I like to indicate in a drill, right? So, or the holder, right? That's another way to do it. I'll throw up a test indicator, maybe a mag base on my chuck, sweep that bore. Well, if you have the tool diameter already set up in the tool and you go to set the physical length of the tool, it'll actually double the compensation because it's expecting that you're actually touching the tool to a side of a part. So just a quick little tip here: when you are setting drills and you want to sweep and work from the center, just delete or don't enter in the diameter of the tool yet. You're going to want to enter it in because you're going to want to see it in graphics. But once you've already set the offset and it takes the appropriate calculation, then you can put the diameter of the drill in and continue on. So if I was to, back in our little simulator here, if I was to load up, we'll say our solid drill, right? So we go back out to jog, TSM, let's grab our solid drill, and I'm working from the center, right? And I have this positioned at the center of my part. So there I am down in the center. If I was to jog the Z in, you'll see it's lining up with the center of my part. So if I was to sweep this right now, with it knowing it's a 7087 drill or whatever this is, it's going to not set the offset at 0. Let's do it really quick. Oops, where am I going? Sorry, hit the wrong button, manual. When I hit set length in X, see how it compensated for the diameter? So the only way for me to set this properly, again, as I was mentioning, is to have this at 0 initially. So when I hit set length, see how it calculated 0. So I would have gone through the steps. I would have had an indicator on my chuck. I would have been sweeping the idea that maybe the bore on the VDI holder here or on the shank of my drill, a bunch of ways I could indicate it. Once I got everything all nice and lined up, right? Now I don't see the tool right now. It's because I deleted the tool size just from the graphics perspective. But this would be how you would do it. Now, if I go back to my offset table, and again, put in the 0.70, I think it was an 87 or whatever. It was a metric drill when it was first set up. See, my drill pops back up. But more importantly, see how my display didn't change? So that's all you want to do. Just when you're using the set length, and you're sweeping in a holder, just make sure you have the tool diameter at 0. Can't stress that enough. Other than that, the rest of the tools are really going to set up all the same. So if I have a grooving tool, like here we have a little insert grooving tool down here, there I would need to have a hole. Generally, when I do a setup, I kind of wait during my first article. I'll drill a hole first, because obviously that's an easy one to do it. Now, once I have the hole in there, I'll stop the job and set the rest of the tools up. Or I just grab a piece of stock and drill a hole, and away I go. I can use that to preset. Okay, so let us continue with our slide deck here. So I did want to talk a little bit about the setup, because obviously it's a big portion of kind of starting to work with a lot of ID-based tools. Now we are going to take a look at 2 different program examples. I am going to program them up for you. We're going to work on this first one where I'm going to be using our standard cycles, and this is going to be using a blank that's already preset with a hole in it. It's pretty common when we're turning jobs to have our stock already preset with a hole. You know, maybe it was done with a manual tailstock, or maybe it was done in a previous operation, or I'm just getting the material coming in from my supplier with a hole in it, right? So we want to talk about how that's going to work. And then when we get to the next example, as I mentioned earlier, we're going to then go through the whole drilling process. So let's take a look at what we got. So we're going to want to start a new program. So that's going to work the same way as any other program would. I'm going to want to go over to Program Manager, start a new program. Now you may notice the screens look a little different, especially if you're on a slightly older system. This is what we call our new skin. So we introduced this for the SINUMERIK 1 control. But your layout, your buttons are going to be really the same. Here we're just driving it off of touchscreen based positions. So on a machine with a touchscreen, the M button that you're used to also becomes the menu select key, and that'll give me all my soft keys to maneuver on the screen. But I'm going to the same area, right? I'm going to Program Manager, I'm going to create a new part program. Once I come in, I say new. I'm going to choose, am I doing a G-code program? Am I doing a conversational one? We're going to work with G-code today, and that's going to launch our ProgramGuide interface. Now, I would suggest if you're new to G-code programming, we have a nice little reference guide that we can provide that just kind of gives you a baseline of some of the common commands and some structure. First page on the reference guide was specific for milling, but the second page was specific for turning. So if you guys don't have this and you'd like it, just shoot me an email. I'll have my email address back on at the end of the event. It was there in the beginning too. But shoot me a quick email and let me know, and I'd be happy to send it over to you. That's our ProgramGuide reference chart. Okay, so we're going to come in, we're going to create a new program, and that's going to launch us into our ProgramGuide interface. So this would be basically the G-code editor within the control. Now, when you come in here, what can be kind of handy is our settings function. So one of the things that we introduced relatively recent, within the last couple of years, is the ability of setting up the graphics to give you different color designations based on operations. So anytime I program a G0, it's going to be displayed in red. You see where my D offsets come in place. They're displayed in blue. My tools, my spindle speeds, all that's in blue. And then my core tool path and my geometries and my cycles are all going to be in black. That breakup kind of allows you to, kind of focus in on different pieces of information a little bit quicker. Now, if you have a slightly newer system and you're wondering how to turn this on, under the editor, if you expand your vertical soft keys, there's a settings button. And when you go to settings, there is a option for somewhere down in here. I think it's the highlighted selected G-code commands, if memory serves me, is the option to change the color. So you can turn this off too. If you happen to have a newer control and you don't like the look of that, you can customize the interface quite a bit. I will show you the settings screen again in the end because there's a couple other things you can use that kind of change the formatting a little bit. All right, so our part setup is going to be a part that's already got a hole in it. Right, we got some tools already created for us, so we shouldn't have to go too crazy in creating or building tools. They are pre-built, and we're going to come in and we're going to face this part to size, and then we're going to do some ID work inside of the part. When we start, we're going to want to start with our standard safety line stuff. So generally in a lathe, you want to be in a G18 plane. Whenever I'm doing any turning, at least, I'm going to want to be in absolute mode. Load up a specific work coordinate. So for this part, I preset it up to work with our G54, and we're going to want a unit of measure. So I'm going to want to be in G700. That's our inch mode. Another interesting command within the control is diameter mode. So as long as I give it a DIAMON, like you see on the display, then the system is going to allow me to type in all X values as diametric values. And then we're going to add our workpiece blank like you see here. That'll set up our basic graphics. And then we'll kind of move around. So why don't we kind of get into it a little bit and start writing our program. Now, let me bring up our part. Should be, nope, not that one. We want this one. Okay, so we look at the job at hand. We have a 1-inch through hole, which we know. So we got to basically turn that out to a 2-inch diameter, and we got to put some chamfers in, a little groove in here, and maybe throw a thread on it. So that's probably a pretty common process I would do when working on an ID type of program. So I go over to Program Manager, and I'm going to build up a brand new program. I do happen to have them pre-created, but let's build a new one while we're here. So go to new, make sure you're selecting the G-code, program guide G-code option, give it some kind of name. So I'll call this my demo 1. Select OK, and now it's going to launch my program editor. So as I mentioned, like here, if I put in a G0, see how it goes red. I can get to the settings screen right here under Edit, expand my vertical soft keys, Settings, and then I should be able to turn that on or off. Yep, and there you see it just goes to black. So this settings area, a lot of guys don't know this is here, but you can do all kinds of neat things to how the interface is going to look. Okay, safety line. So as I mentioned, turning, you always want to be in G18. So whether you're ID or OD turning, it's going to always start to be in G18. Absolute is going to be our G90. I happen to pre-establish G54 as the face of my part. And I want to be in a G700 for my units as to be an inch. I could probably put it on the previous line. I don't know, out of habit, I always put it on its own line, but I do want to establish diameter mode on. That's a command. It's typically a power up and a reset strategy of the control anyway, but it's not a bad idea to get used to it, because as I start getting into more complex stuff, like maybe I get a lathe with milling capabilities. Well, when I get to milling, I probably want to turn it off. So it's something that you will turn on and off, especially when you get into a little more advanced content. Generally at this point, I like to set up my blank, and the blank is just for the graphics. So here I can come in, I can tell it, what kind of shape am I doing? So in this case, I'm going to use a pipe. What is the rough stock? This is a 3-inch blank. I got a 1-inch hole in it. How much material do I have in the face? So I'm leaving 1/10 out for a facing cut. Overall thickness, this part is -2.5. And I don't know, maybe I have 2 inches sticking out from the jaws. That's something that I would play with. I know what my nesting would want to be. So you accept the cycle, and it's going to put the cycle in as a G-code string. Now, any of our G-code cycles you see here, just click on that little arrow and you can open it back up. So whether the cycle was posted from your CAM system or you input it here, you can always edit it conversationally. Now that I have my initial safety line and setups, and that's pretty common what you're going to do on every job, you're probably going to want to grab a tool. So I do have to face off this part first. So why don't we go grab a tool? So if you hit the edit button, you're going to get, and I have to expand my vertical keys back because I was in the settings area. You're going to get a soft key called select tool in the upper right hand corner. And what this is going to do is it's going to give me the ability of seeing the tools I have available for me. I can hit tool list again and go all the way back to the tool table if I needed to build a new tool. But if I want to grab a tool that's already created, here I got a standard 80-degree roughing tool, OD, right? Because it's an upper turret, so that would be kind of how the insert would look in the machine. I can now hit to program, and it's going to put in the tool call for me, and I'm driving it based on the name of the tool. Now, get in the habit of using your D numbers, because maybe I want to use a different D number, right? We were just looking at that example. So I'm going to put a D1 right now, making sure that I'm grabbing the first offset. Now, on a lathe, traditionally, you do not need an M6. Now, I say traditionally because some builders with more advanced lathes, specifically lathes with milling spindles, like a B-axis milling spindle on a lathe. If you ever see those sophisticated 5-axis lathes, like a turn mill, or some people like to call a mill turn. In that case, there may be an M6 or some kind of a macro call additionally needed. But traditionally, if I have a turret or a tool post, no M6, the T call by itself is going to be enough. I don't do prefetching in this scenario, right? So with that case, then I'm good. If I do another T call, it's going to spin the turret to that new location. Give me some RPM. So let's do a little bit of straight RPM work. I'll just throw my spindle up at 2000. Do want to turn on my spindle. So that would be like an M3. Maybe turn on some flood with an M8. Probably going to want to make sure the machine is in G95 or feed per rev mode. So G95, F, and then give it some feed rate, right? So this is pretty standard for the G-code side. When it comes time to get into machining, and this I'm going to stress when we get to the ID stuff, I want to pre-position the machine around a little bit, right? So here I'll probably do a rapid just off the part diameter, maybe just in front of the part. And now I could do this as straight G-codes, or I like to use my stock removal cycle under turning to handle my facing operations. So when I get into these routines, you'll notice there's a couple variables that I normally didn't have to worry about in shop turn because they were set up in the header page. There is no header page in G-code. So since there's no header, I have to tell it the safety distance of my part right in the cycle. Here I got some feed rate. Now if I'm going to face off the part, I'm probably just going to do it in one pass with a finish. I want to be in the OD, but I want to be in a face, so I cut from outside in. Give it my stock of 3-inch, my rough, I think I said there were 10 thou on it. I'm going to end slightly past. Now in this job, I got a 1-inch hole, so I probably don't have to go all the way down to 0, but I probably would want to go to maybe 900 thou and go right to 0. This is going to get me to a position where I should face off the part. Now what I don't know is where do I want to go after I'm done, right? And this is a scenario, and I probably want to maybe even add this before my tool change, where I need to have a safe predefined location. So what I normally would do, all right, is back in the jog environment, I would pre-position my machine to some location where I feel it is out and away far enough that I could easily spin this turret. There's no chance of me colliding in anything. And this is going to be my, what we call our SUPA location, right? This is going to be my predefined location that I'm going to use to do my tool changes. So what I need to know with SUPA is I need to know where am I at relative with, without any tool offsets. Where's the machine coordinate system? So if you click this little button right here, this actual machine values, so you get the MX and the MZ display, this is your machine coordinate system. So I look at it and I say, okay, well, I could easily then maybe send this machine to a Z position of maybe 20. Maybe I go out a little bit bigger. We'll go out to an X value of 10, right? And that would get me into position. But the X, you want to be careful with SUPA, because it is going to be dependent on the diameter mode being on or off. So my diameter position is really 12. So if I said 10, it would come in a little bit more from here. But the Z location is the actual value. So this is a command or a position I can now use inside my SUPA command. So SUPA, it's a suppression of the active offsets, is as simple as typing SUPA. I want to probably tell the machine I'm in a rapid mode. I do want to cancel all active tool offsets, and then I can give it a position. So I think I said, I don't know, maybe I'll go a little bit more. I'll go out to X of 15 and a Z of maybe 20, and that would be my safe retract position when I'm done. And I usually will use this before any tool changes as well. So I like to have my SUPA right there. This way I know I sent the machine to a safe spot. At this point, I could add a quick little M30, and as we simulate it, we now got a program started. No ID stuff yet, but we have a little program started where I face off my part. Okay. Next step would be handling this internal bore. So if we take a look at this now, later when we drill just smaller, whatever drill design. Go into cycle. We're just going to flip it upside down a little bit in order to cut this part from the inside out. Then you notice once I do my SUPA, and this is pretty important, you always want to make sure you do a retract in Z. So some cycles, especially in G code, could leave the boring bar in the part. And if I just went right to a SUPA, I could literally move through the part. Now, the beauty of simulation is it should show me that. But when you're working on internal work, I would say always veer to the safer side. It's not going to hurt you to do a little extra rapid command to make sure, hey, let me pull my Z in front of the part before I go into the next command or next instruction. Okay, so I'm at a safe spot for tool change, right? So we can now go back to edit, select tool. I pre-created a ID tool. This is our roughing tool here, so we can go grab that. That's the boring bar that you see right over there. Right, that'll be that little boring bar that we have built in the turret. So let us add that in. Remember, oops, that's weird. We selected again, deleted it. Remember to give it your D1. We can reissue our spindle speed. I'm just going to stay in straight RPM for this example. Certainly you guys could get into G96. I've shown you all that good stuff in previous webinars. I like to certainly repeat some of these M codes. This way, if I mid-program start and I don't want to have the scan on, I can do that. I am a big advocate of reissuing my G95, although it's not required by any means. Maybe I'll run 20 thou per rev. And at this point, remember, I'm out at my super location. My turret just spun, my spindle just started or adjusted an RPM. It knows the feed. So now I'm going to rapid down to just smaller than, oops, helps if I give it an X, just smaller than my hole diameter, somewhere just outside of that. So that's going to position the turret, oops, right down here. Now I do need to change this job when we get to it. So let me do that now real fast, because remember my blank has a hole in it. All right. So I'm positioning just below the hole that's already in the part. Now we can jump into our turning cycle, stock removal. And at this point, we'll bring up our print. I can define this shape. Now in this shape, I got some chamfers here and there. So if I use the second option for my ID or OD turning, now I can get the chamfers in. The big thing to remember when you're ID turning is to change this symbol. So by default, it's usually at the OD orientation. So that's what signifies whether the operation is going to be OD or ID in our cycles. Pick that little image, change it to ID. Now I do want to do roughing. So this was a carryover from maybe the last time the cycle was used. So I want to make sure I'm doing roughing. And then it's really just fill out the page with some basic geometry, right? So safety distance, how close do I get before I start feeding? Maybe a feed rate. So I'm going to go 20 thou. What's my starting diameter? So now it's going to be 1 inch because that's my hole. I've already faced it off, so I can start at 0. My ending diameter is going to be on my print, so that's a 2-inch diameter. And if I look at the back wall, 1.5 inches back. And then we have our 3 little potential chamfers or radiuses. You can toggle this, right? So I could put a radius on the front or a chamfer. Now, if the item or the corner doesn't require anything, like this back area, then just leave it at 0. It doesn't matter if you leave it at a radius or a chamfer. So here we got an 0.75, and my last one would be my transition between the face and the bore. I want to have an 0.75 per my print. Some kind of depth per cut, a little bit of material for a finish. I'm going to bring it right to size for time's sake. And when I'm done now, this is where I was saying before, make sure you get in the habit of getting that boring bar out of that hole before you send it anywhere else, because it could be left. In fact, this cycle does leave it inside the hole, so that would be a problem. Grab your SUPA. I can reuse that one because that's going to be my safe position for tool change. Take a quick look, and now we should be starting to see something that looks like our part, right? So there's my face, there's my turn. If I want to see what it looks like in the real world, well, we can now jump over to auto, fire it up, and you'll see we're going to do a facing cut. This always takes a second to fire up. she goes. So spindle spinning, face cut, and now you're going to see my boring bar comes in. I have my predefined hole. So it positioned to the 900th thou, and then really use the 1-inch starting point to know where it was going to start cutting from. We got a nice little lead-in chamfer. If I zoomed in, you can see I got a little back chamfer right here as well. So my part is on its way. From there, it's really kind of flip through my operations. So in this case, I did have a groove. So I wanted to put an ID groove in the part. And then after the groove, we're going to do a thread. So let's take a look at an ID groove. Now, when we build the groove tool, it's important to kind of define where the reference position is. So we're going to take a look at that here, because when I set up the tool, that's where it knows where the actual backside of the insert is. So we track the backside of the insert in a grooving tool. So back into my program, we're at a safe retract position, so we can go select a tool, and I'm going to go all the way to tool list, because you see how I built this grooving tool in Pocket 7. So that's just going to be, let me zoom back, give you a little shot of it. That's this tool right here, right? A nice little grooving tool. Well, when I define this tool and I go to set the offsets, right, I'm using the third one over, you see right here, but you notice that there's these little indicators. So I could really use the third or the fourth, but that little indicator, if you can see that little icon in the corner, that tells me what my kind of my leading or my datum edge is. So when I touch off this boring bar, let's say I touched it off to the face of the part, maybe it was 0. As long as I was touching the left side of that insert to 0 and I set it to Z0, now it's going to know that, okay, the width of the tool, which happened to be 118, is going to the right side. So that's really the most important part when you set up a grooving tool, is just paying attention to this little indicator. So when you build the tool and give it your radius and give it your insert width, then it knows what direction to create that in. So we got our grooving tool in. We'll just, I'm not going to be very creative for speeds and feeds today. I'm just going to keep using the same, just so you kind of see it, whatever. Oh, I want to pre-position. Now in this case, my pre-position is going to be relative to what I've just machined, right? So I just machined a bore that is out to 2-inch diameter. So maybe I can come down to 1.9, helps if I put an X, come down to a Z of 0.1. Now I wouldn't want to give it a Z negative, or I would send that boring bar right through the side of my part. So I can come down into the front of the part and then maybe do a Z minus, I don't know, -1 or something if I want. Let's bring the print up here. So I know the backside of this thing is all the way a little less than 1.5 inches, right? It's 1.450 is a little gap there. So I could move it down in here, but the cycle will actually bring it into position. So I don't usually add this extra Z move in. I typically would just get it down right off this face and right underneath that bore, that OD or that ID, I mean. And then I would jump into turning, go to my grooving cycle, and then this will bring her in position. Now, when you set up the grooving cycle, just like when you set it up on an OD, all right, I got to give it my safeties and my feeds. Tell it, am I roughing, am I finishing, or am I going to rough and finish all with the same tool? Maybe I'll do it all with the same tool. Now, this lower first icon, this is going to define whether it's an OD, face, or an ID groove. And then this indicator has to do with where the X and Z datum is. So it's not the 0 location of the tool like I showed you. You don't have to pick a left just because the tool defined was on the left. But this is going to drive where these two numbers are coming from. So you can position that all over the place. It could be the back side, it could be down in the groove. It's just signifying where the X and Z starting location is. So I'm going to use this lower corner, right? So 2-inch minus 145, that's that position. Width of the groove, I get that off my print, 200 thou. Depth of the groove, that could be either an incremental or an absolute diametric position. Do I want to peck? How much do I leave for a finish cut? And then if I happen to have multiples, I could do a pattern. So I defined the cycle now. I hit accept, drops it in. Now, just like before, always a good habit, get that tool up out of the hole before you send her to your safe position, which is your super command. Isn't the colors nice? I really like when we introduce the different colors. I think it really does help kind of just with the focus of your eye, bring your attention to different spots. Okay, so let's get in our final operation here. In our slide, we're just going to come in and put a threading tool in, and we're going to throw in a single point threading cycle. So let's do that real fast, because we do have one extra job to program, and I want to have time for you guys to ask some questions. All right, so final, we're going to go grab a thread. So edit, select tool, find our ID threading tool. That, in my case, is going to be this tool down here. Set up a simple little ID threading tool for us. All right, some speeds. All right, make sure the spindle's running. Now, G95 with a feed rate really doesn't matter because it's going to feed at the pitch of your thread. I can certainly put it here. It's not going to make any difference, right? Certainly if I was going to do some other feed move, which I normally wouldn't with a threading tool anyway, so it doesn't make a whole lot of sense. Let me give us a little bit of room here. All right, so I have my feed per rev. I'm going to now come into position. So this kind of stuff is pretty consistent when you're working on ID jobs, right? Always get in the habit of pre-positioning the tool. So I'll go maybe 1.9, something a little bit smaller than the hole. And it's really just like I did before. And at this point, once I'm in location, I can go right into the threading cycle. So turning, threading. When you get to ID threading, it's really just a matter of flipping this one variable from OD to ID. And now I'm inside the thread. Other than that, it's the same exact cycle. So if you've done any threading at all in the control, it's going to work the same, right? Define the pitch, roughing, maybe rough and finishing, digressive or linear, right? Constant depth, constant volume. I always like to use digressive whenever I can. Starting position, so that's my bore, happens to be 2-inch. I'm starting from a position of 0 facing my part. How deep is my thread? So I'm just going to send it somewhere into this groove, because hence that's why the relief is here. My overrun, or my starting position. So the Z0 is a physical point on your part. So this would be some value to start, just to make sure that that tool is up to speed before it engages with the part. I can do a lead out, but if you leave it at 0, it should do a rapid retract out. Thread height, angle, you know, all the normal stuff you would set up for a thread. Maybe I want to do a little spring cut. Once you define threading cycle and drop it in, now it really just be about done with the job. So I am going to, again, get in that habit of doing a retract. Now at this point, I may want to shut my spindle off, shut my coolant off. I'm probably going to want to do our safety retract. But there's one thing I want to make sure I do before I stop this program, and that's all about this D0. So the D0 cancels the offset because SUPA by itself doesn't suppress the tool offset. SUPA is a non-modal command. So it's going to say, hey, G54 doesn't exist for the length of this move, but it's going to reactivate it when I'm done. D0 is a modal command. So you never want the machine sitting without the known tool having its offsets. Now, previous, this wasn't an issue because I was driving right into a tool change. And in my tool change, I was going to have the D1 anyway, right? But when I'm doing this as an end of program, I like to make sure that I reactivate the cutting edge that's loaded, or spin your turret to a location that has no tool in it. That's another option. We do a final sim, and we should have a complete part. And if we want to take a look what it would look like in the real world, we can take advantage of our nice little machine simulation here. I do need to reset the part blank there. I like to, when I'm using this digital twin myself, I like to bring up my simultaneous record so I can kind of see what's happening inside the part at the same time as it cutting. All right, so this is all kind of real-time, one-to-one. So there's our little face off coming in, starting to bore the ID of my part. Now we're going to go in and we're going to groove. So you notice the cycle took care of positioning the tool inside of my bore for me. Now we're just cutting that groove. She'll take a little finish cut here. There's your finish pass. And then now this is my wrap it out to 1 inch away, load the tool just to make sure that I don't get into a scenario where I clip my part. Now we're doing our single point threading, right? So come on through, depending on how many passes, based on my starting and my chip load and all that good stuff. There we have it. We have a quick little part. So that's really a kind of a good start. I mean, you know, there's not a lot of differences OD to ID. Really the big things is just kind of paying a little more attention to where the tool is, because you have a little more crash potential, right? So add those extra retracts from a safety perspective. Maybe get in the habit of pre-positioning the tool in before you go right into an operation. But other than that, it's really kind of the same steps you would do when you start, when you would do OD turning. So for us, I do want to show you the contour turning, because we don't always have the luxury of physically handling a part that uses our standard can cycles. So in this shape, we're going to actually draw a contour. The other thing I do want to talk about is physically drilling the hole. It's important for us to at least have talked about how to drill a hole, because the cycles are going to look a little different. So our part, we will switch over to our solid blank setup so we can see it physically drill the hole. My safety is going to be, safety line and start of the program is really going to be identical to the one I just did. So I'm going to show you a quick, simple way of copy and pasting between part programs. And then when we get to drilling, now we're going to load a drill. In this case, we're going to use a 3/4 inch drill that's been pre-created, fire up our spindle, and then we're going to go into our drilling cycles, and we're going to talk about that a little bit. So let's start that program. So from a programming standpoint, it's going to be the same like you just saw. I'm just going to go over to the program manager. I'm going to say we're going to do a new program, and we'll build it from scratch. We're going to call it demo 2, we'll say. Fire it up. All right, so I'm in my editor. Now let's say I have similar content that I want to grab from another part program. My facing operation. How many times you do a facing operation? Why should I have to recreate that every time, right? Now, one of the differences here, if I notice the stock, this is, it's pretty close actually. This one was coming out from 3.150 or 80 mil, where the previous one was a 3-inch diameter, but I might want to adjust that a little bit. But other than that, there's not a whole lot of difference between those two operations. So if I want to gain access to another program, we have this cool function under Edit. If you expand your vertical soft keys, you can hit the Open Further Programs button right here, the vertical soft key. And that's going to give me my little menu, so I can drive through all of my different mediums, maybe even my USB stick. But I can now have multiple programs open at the same time, and you can open a bunch of programs. So if you wanted to, or maybe you were working on a multi-channel machine and you wanted to see both channels up at the same time, you can do that. My case, I just want to grab all this stuff, right? I want to grab everything up to my second tool, my second operation, because this is really all the same I'm doing. So just hit a copy after I've marked it all, jump over, hit paste, voila, I just grabbed all that great information. Now when I want to close or shut down this program, put your highlight or your cursor back in that program that you want to shut down, expand the vertical soft keys, you get a close button, and that'll close it up. And now you can open or close it as much as you want. Nice, quick, simple way to jump between different part programs and grab some content. So in this scenario, I want to be at 3.150 as my stock, and I do not have a hole, right? So I want to be just in a cylinder. That's a difference between the two. When I pre-position, I'm probably going to want to be outside the rough stock, so I had to add just a little bit in my X move. And we want to open up the face because now I'm going to face the whole part down. I want a nice clean surface for when my drill comes into contact. So maybe I'll just go past the radius of my tool. But boom, we have our little part faced off. Okay. Now I do get in the habit of maybe putting my M30 in just so it's there. So when I simulate, it'll kind of push down on the program a little bit. In the job, all right, we'll minimize that. The next thing is going to be setting up the drill. So why don't we do that? Why don't we go and we build the drill? So we've already established the drill, found the zero, built it. Building it's no different than building a drill. It's pretty straightforward. There's not a lot of information there. But I want to work with the drill. So that's where things get a little different. Okay, so I'm in my safe position. Jump over to edit, expand back so I see my select tool and find my drill, right? So when I built the drill, I just created simply like this, right? New tool, picked my drill, the way it's pointing to my chuck, gave it some name. Eventually I set the offsets later, gave it a diameter, and then on regular drill, I would have an insert or a drill point angle. So I would define that. The solid drill that I created earlier, that's found under the drilling options. And that is right here, solid drill. And in that case, really the only difference is you notice it doesn't have an angle because it's an insert drill. It knows it's always straight. So our drill is up top in turret position 5, our 3/4 inch drill. Speed, I don't know, maybe we're doing 1,000 RPM. Certainly I wouldn't be running constant surface feed with a drill. Fire up my spindle, my M3, maybe I have coolant, M3, M03, totally up to you, right? It's the same command. Now, I do want to give it a feed per rev of, whatever I know I need to run with that drill. And this is the important part right now. This is the big carrot that you've been looking for. You must pre-position the drill on center line of the spindle. In shop turn, it does it automatically because you have this whole centric drilling series of cycles. In G-code, it's the same cycles whether you have live tooling or not. So we're leaving it up to you to pre-position the drill. So you have to tell this thing to go to X0, or if it's an insert drill and you can do a little bit of an offset, right? Insert drills do allow you to drill not right on 0. You do have to look at the maximum you're allowed to be off with any given drill, but you're going to be very close to center line, right? So you got to make sure you get it into position. Z, maybe it will be 100,000. So she's going to wrap it down to position because when you go to the drilling cycles, you notice nothing says centric. So it's up to you to pre-position that tool. Then you can go into drilling, fill out the page. So this is pretty straightforward, right? Drilling is a feed to depth, wrap it out. Deep hole would be my PEC drilling cycles, a bunch of different scenarios there. I've gone into all these cycles in depth in other previous seminars, but you come in, define the drill. Now, when you drill in a lathe, you do need to be in G17 mode when you're on the face. With that being said, if you define the plane inside the cycle, it should go back to the modal plane, which, if you remember, was G18 in the beginning. But it's not a bad idea to get in the habit of still giving it the G18. There was a question about diameter mode off. You do not have to shut diameter mode off because in this case, I'm just sending it to 0. So that's okay. If I was live tool drilling, then I probably would turn diameter mode off so I could position radially. But I can just keep diameter mode on. Just remember that my X locations would be relative to that. So retract, where do I go when I'm done? How close do I get to my part before I start to feed? What is the front of my part? How do I want to compensate for my overall drill? So if I use shank, it'll use that 118 it knows. So I can program the overall thickness of the part, which is 3.150. And I better make sure I did my blank properly. I don't think I increased that. What's nice in the standard drill, if I want to do a quick little spot drill at a lower feed and spindle speed, I can do that. It's the same drill, but it allows me to kind of create its own little pilot before it keeps going. If you don't care, you can just come right in and it's going to feed at the same feed rate. And then we do have a little overrun. If I was tapping or something, I could do that. And then we have our dwell. Now, if you're going to use a dwell, and you know, in some cases it's nice to use a dwell, especially when I'm breaking through. I might want to make sure that I just broke through and didn't leave anything like a chip hanging on the back side of that part. I typically don't like to use seconds. I will toggle this to revs, and then this number becomes the number of revolutions of the spindle. Just a lot quicker, right? I could put 2 seconds in here, but 2 revs is going to happen a lot faster than that. And that's all you need, right? You just want to make sure that that spindle revolves a couple times before you pull that drill back out of the hole. So by inserting it, now we just drilled our hole in the center of the part. Now it's going to retract out by its nature to a positive 1 inch anyway. So I don't have to give it that Z retract at this stage. I could, it's not going to hurt me, but I do want to make sure I reissue the G18 just in case, right? Technically, the cycle is switching you to G17. And next, we're going to do some turning. I have to be in G18. So it's a good habit. Makes it a little more deliberate too. We can do our SUPA. That's going to pull us out and make it ready for the next stop. So let me just tweak my workpiece blank. Yep, I didn't adjust it. So this is 3.150. And then obviously how much I have sticking out of the chuck jaws, I can leave that alone for now. Simulate it. Oops. Huh. Looks like there's an alarm that I can't see. It's funny. I actually can't see the alarm. So let's just do this. Go to our alarms. Syntax error. Okay, so I had a typo somewhere. Let's see where my typo is. Oh yeah, forgot my F. Okay, so let's just finish it up. So in this case, remember I'm programming based on the shank of the drill. So there you see it pokes through. Had I not done shank, then I would see the full tip here because then I would be only going that 3.150 to the tip of the drill. Had I forgotten to preposition or preposition it somewhere else, it would have tried to drill this hole off center and graphics wouldn't have known that this machine's not capable of that. So that is on you. You have to know enough to say, is this a live tool or is this, let me put my D1, is this a live tool or is this a static tool? If it's a static tool, make sure you get her to 0. That's important. Okay, when you get to contour turning, what you do have to do is you're going to use our contour editor. So certainly if you've used this before, an OD turn is going to work the same. I like to have my contours after my M30, but they can be all kinds of places. They can be in external part programs, they can be subs. There's all different ways to call a shape. So we're going to create it there. And then once we do that, we're going to set up the actual operations. So we're going to load our tool, set some speeds and feeds, call up the cycle. We'll show you how to do all that and then send her to a safe spot. And we'll take some questions. All right. I do see some good questions coming up, so we're going to get a chance to go through them shortly. So when I do the contour, I like to put it down here below my M30. When you're going to get into irregular shapes, you got to go to the contour turn button. And then I'm going to go into the first upper right-hand contour vertical soft key. And I'm going to create a new contour. Now when I go to new contour, give it a name that's recognizable for you because you're going to have to call it up again. So I'm going to call mine ID turn. And now you're in the editor. Now you can change the name if you don't like what you put, just right here. So when I get to doing ID contours, right, it's gonna work a little different. Normally on OD, I'm used to working kind of like from the center line out. So you work in reverse here, right? I'm gonna kind of draw it from the largest diameter in. So our largest diameter happens to be 65 millimeter or 2.559. Quick little trick. If you're working from a part print that is, maybe it's got metric values and you're in an inch program. If you type a quick I next to the number, it'll convert it for you. Look how cool that is. Same thing, I go 2.5 M, it'll convert it to a metric value. So it's independent of whatever unit of measure the systems is, but it's nice because now I'm not getting rounding error. It's going to round it for me. So it's the number and then the I for what unit of measure I want it to convert to. So we're going to start at 2.559, Z of 0. Now, if I want to get a chamfer, which I want on the front of this part, I'm going to use my chamfer radius transition to start, give it the size, 0.079, and now you're going to use this arrow to signify kind of the direction. So normally up would be for an OD shape, so down would be for an ID shape. If you get this wrong, it's just gonna draw it in the wrong spot. Now you will need to have the first event as well as the second event in before you'll see it. So this is just this next line move back in Z. So that's a negative 30 mil. So we'll convert that to an inch value. I don't need any chamfers or radiuses at the back of that bore, but now I see my nice little chamfer. And keep in mind, this is a slant bed, so it's drawing it on the top because that's where my tool would be coming from, right? Now that I have that, I'm going to do a little 2-axis move here. We're going to come down to a bore that is 45 millimeters, so 1.7717 or 772. It's going to be back negative 40. So we'll convert that. And we have a nice little radius. The radius is going to be 0.394 per the print. If you guys ever want any of these prints, just reach out, send me an email. I'll be happy to send them to you. More than welcome to use them for your own little training examples. Now that I've come up this slope, I'm going to go back to negative 2.362 or 60 mil. So this example, it's much easier to type 60 and convert it. All right, there's the back side. Accept. Now we're going to pull off the hole, come all the way out to our final hole, which is, I think it's a 787 or 20 mil. Yep, 20 mil. I do want a chamfer there of 0.79. And now since I drilled it with a 3/4 drill, I'm going to want to send that boring bar through there. All right. So I'm going to give it a Z move and probably go to the 3 point, maybe a little bit more, 3.2, right? Remember the stock's 3.150. Now, if I just want this tool to just go straight through here and I don't want it to take any roughing cuts, then don't do a pull off at the end. Now the system will allow the tool to go beyond this point by the radius of the cutter. So just be careful if there's a blind hole. If that would be an issue, then you would want to pull a retract in X. But if that's okay, like in my case, I'm just going into the spindle bore a little bit, I would not pull a retract out. Now, if I had a lot of cuts and they needed it to turn in here, then I would want to add a retract. So by plugging this in, what you get is this little contour at the very bottom of the screen. It doesn't matter what line you're on. If you hit that little arrow button, it'll open up the editor and then I can re-edit it. But when it's time to do it, we have to come up here and set it up. So let's go grab our ID turning tool, like we used before. So I'm going to grab this ID turning, pull up the appropriate cutting edge, D1, make sure my spindle is running at some RPM, some speed, used to my feed rate, F whatever. Okay. I am going to probably preposition. That'd be a good habit to get into because I did just drill a hole. So I can send the tool to like an X of 0.750 or 740, right around the hole size, Z just off the part. Now, in G code, when I'm going to use a contour, I need to call up the contour. So it's still left in this contour function, right? So I use the new contour to create it, but I can have a whole bunch of contours down there. When it's time for me to use it, I got to go call contour and I got to type in the name. Now, this is a carryover because I had typed it in earlier. Normally this is blank. So that's why I said use a nice simple name because you are going to have to repeat it. Once it's there, then it's a matter of just calling up the stock removal cycle. So stock removal cycle is going to work like you're used to. Now this is a little newer software, so you may not be used to this. We used to make you have to put some kind of a name here, and it created a program in the background that it would use for residual material or for some other advanced functions. Now we have this auto option, and it'll just do it all automatically for you. So that's something new. I think we released that in maybe 4.8, if memory serves me. The rest of the page is going to work just like your OD turning. Just remember, you're going to change this from outside to inside, and you do have to give it a retraction point. And in this case, it's going to have to be an absolute value. So I'm using a value just smaller than the hole that I drilled. Everything else is the same. Depth of cut, finish amount, right? You don't have to worry about playing around with signs to designate ID or OD. You know, everything's driven right from this field. So if you accept it, and now we'll do our quick little end of program. So maybe I'll do a M5, oops, M5, M9, throw in our SUPA, just like we did before in the last job. We'll make sure we reissue our cutting edge when I'm done. This really would be a kind of a finished up program. So let's see if we got it all. Let's jump over to execute. Bring up our graphics. Is this the right part? Nope. I need to change to our the part with not a hole. Right. So there I got my blank, slightly different in size. And let's fire it up. Whenever I switch blanks, it always takes just a few seconds here to kind of catch back up. I think the model's kind of rebuilding in the background. So first thing we're going to see, faces off our part. Oop, well, that's not good. Ah, what work offset did I see? See the red? It's crashing. That's what's cool about this. I could have done this on a real machine. That would have been ugly. All right, so I think it's the work offset I set up for this one. So I pre-staged these work offsets, and yes, this one's set up for 56. And our program we just made, we use 54, so that would be ugly. Now let me do a quick check, and now you can see the benefits of a digital twin. All right, so let's reinitialize, bring up our graphics. So the simulation would have had no idea that that was occurring. There we go. Looks a little better. Now here is an example where we can see some nesting issues. All right. So I got my bars are hanging out and my part wasn't projected enough. So that's a scenario where I would have never noticed that just in regular graphics alone. It's where really when you can start to reproduce these scenarios, it becomes very handy to kind of see what I have to do. So how would I handle fixing that? Well, I could just turn off the collision avoidance. That wouldn't fix the problem. But really I'd have to either space out my tools. If I have enough locations in my turret, I could stick the stock out a little bit. I could go to a soft jaw that maybe projected the stock out away from the chuck face, right? Those are all the things that I need to start thinking about when I'm dealing with nesting types of issues. But here you see the part. So if we look at it again real quick, we'll just reset it. So we face off the part, right? Looks like my blank's off a little bit. Drill our hole. and then we come in. So you see how the turning tool never went into the hole? That was, again, that's because I didn't pull that retract move. If you add a retract, then it'll come in and it'll try to define that. But I do want to get to some questions because I know we're running late, and I see a bunch of questions here in our Q&A panel. Additionally, let me bring up my final slide. There were a couple extra things I was going to show you guys in that settings button. One thing that's kind of cool in settings, if you hit display cycles as machine steps, then it won't show the cycle in the mask, right? It won't show that cycle string where it says, cycle 95 or whatever. It'll show, it looks a little more like a conversational program. That's just a display formatting thing. Also, you might have noticed that my program didn't have any of the end of block symbols that we usually see. You can hide them as well in settings. But let us get to the Q&A. How to switch to capital letters on the control. So that's a couple different things. If your control by default is automatically just in lowercase, that's a machine parameter. So if you want to set up the system, show you real quick, to power up and default to caps, go to setup, right? So menu select and setup. Go to your machine data, expand over until you see the display MD button. Under display MD, I think it's the second one down, let's hit help, is caps locks, right? So a 0 would be caps locks off, a 2 would be caps locks on. So if you set this parameter to a value of 2 and reboot, see the PO, it's a power up parameter. So reboot the system and then your system should be in cap locks. So I'm assuming that's what you are asking about that. If not, type in again and I can readdress the question. All right, so let's go through some more of the questions. So we got a bunch of stuff here over in the chat window. Yeah, it looks like that's what you were asking about. Perfect. Okay. Andre asks, will the software show collisions of the tool? You just saw that. I totally crashed the machine. And workpiece in case a mistake in the NC program is made. Yes, it absolutely will. What's kind of neat with this new software, not only does it show it at the time, but it keeps a record of it. So if I hit this little collisions area, I can actually start to designate and see. You can clear this. So if I have a bunch of stuff from previously playing around, I can clear it. But it gives me a little more of an idea of what collided with what and at what point was I at when it collided. All right. Do you turn off at end of program diameter mode off? No, not typically in a lathe. So typically in a lathe, I usually always leave the machine with diameter mode on. And in fact, the system is probably set up by the OEM to be always on diameter mode on. So an easy way to see how your system has been pre-configured, just do it in jog or in auto, but you want to be sitting in a reset state. And you're going to come and expand your vertical soft keys until you see the all G codes function. When you click on that, these are all of the states that are set up by default to be your power on or your reset state. And if you look right here, my machine is set up to be a 29. So even if I put diameter mode off just before my M30, it's going to be back on again anyway. But I still like to show you guys diameter mode off and diameter mode on, because if you have live tools, you will bounce between diameter mode off and diameter mode on. And if you look at some of my other webinars that I got into some of the live tooling, you'll see that I was doing that when I get into milling and drilling, specifically off center. Centric drilling on a simple machine like this, there's really no benefit to switching. Okay. Let me come down. The arrow points in the direction the tool is going. I think Dan was referring to when I was in a cycle. So here, oh, not that cycle, probably the contour turn. Let me go back into the other one. Oh, demo mill, that's what I wanted. Here. I'm thinking he's talking about this arrow. So that'll designate my machining direction. So I didn't spend a lot of time going through all the nuances of the cycle. I've done it in a million other webinars. Certainly if you're new to these cycles, I would suggest taking a look at some of the other webinars. I went into a lot of this in a lot more detail. Today, really, I wanted to point out the differences when I switched from OD to ID. So that's what I was kind of trying to stress a little bit. All right. Are there any ways to describe customized work pieces in the beginning of the program? So if you're referring to our workpiece blank, unfortunately, no. When I get to this machine space model, this is an STL file, so I can make it look like anything I want it to look like. But when it comes to the standard simulation, you are limited to your basic primitives here. So cylinders, pipes, blocks, and hex stock would be your basic primitives for graphics. All right. Tom said, great presentation. Thank you. I appreciate it. What about diameter off on a mill turn? So John, yeah, diameter off on a mill turn, it's really going to be up to the OEM if that's the default reset strategy or not. I would say typically I see that diameter mode on is still, but when we talk about mill turn, let's quantify that. So this is where things get confusing. The industry, as of 10, 15 years ago, the only machines really on the market that were what we consider or think of as a mill turn were actually what we at Siemens call turn mills. So we like to differentiate. If your base technology was a turning machine that milling capabilities were added to, that's what we call a turn mill. And in that case, I would say the default strategy would be diameter mode on. If your machine is fundamentally a milling machine, like a 5-axis mill that has a torque motor and can do turning capabilities, in the DMG portfolio, they call it an FD machine. That is what we call a mill turn. And in that case, the default strategy would be diameter mode off, because by default, that's a milling machine. And milling machines, you generally would not have diameter mode on until you went to a turning scenario. So just keep that in mind. What is the fastest way to change? You guys are great, asking a bunch of questions today. Perfect. What's the fastest way to change the retract distance between passes in the internal turning cycle? Important for the first pass of an internal turning. That's a good question. So one of the things you can do, and I'm trying to fully get my head around the question, in the contour turning cycle, you can have some control over the retract based on these icons here. So the initial is going to take its first cut based on my starting location and my depth per pass, right? It's going to back off from there. But beyond that, it's going to back up the cut amount, but only if I have that at a full L. If you leave this as just a straight, it's going to just pack up a predefined amount. I think there's an MD that controls that value. Or if I have it at the straight with the dotted line, it's only going to back up when it sees that I have some kind of angular geometry. So that keeps me from getting kind of that like chunky kind of triangular pattern that I would normally traditionally have seen in a turning cycle. So normally I set it for a full contour turning, but then in this case, it's always going to be back up the cut amount, and then there's an additional retract, just so you're not dragging across the part, and then away it goes. So I think that might be what you're referring to. All right. When is creating my virtual machine software available for purchase? Okay, so it actually is available now, currently. The software itself was really designed around the SINUMERIK 1 control, but could be used to even demonstrate other control systems, so it's possible. So if it's something you guys are interested in, reach out to us and we can explore it further. But it is open to the market right now, so it is fully available. All right, I think, Oh, I see what Dan was saying. He said when you're drawing the first chamfer, he was talking about that arrow scenario. So what Dan was mentioning is back here, when I first set up this, the arrow is cut direction. That is correct. So my tool would be moving towards center line when I am going to put this chamfer. So I think that's what he was referring to. Okay. Well, I think I got everybody's questions. If I didn't, by all means, feel free to reach out to me. Put it up one more time. I appreciate the great attendance and all the great questions. You guys are always welcome to reach out to me. I will send you also out a link for this webinar. So in the future, keep an eye on what's coming out, and look forward to talking to you guys next time. Thanks everybody for joining, and have a great weekend. All right, take it easy.